Welcome to solverfy.
Okay, so in this problem, we are given this diagram, which is a collection of H2O and CO2 molecules. And from this diagram, uh, we have to find out the empirical formula of the hydrocarbon, of which combustion we get this diagram or this collection of CO2 and H2O. So to do that, first you have to identify which one is CO2 and which one is H2O. So if we write down the structural formula for each compound, for CO2, C is in the central, and we have two oxygen in two side of this. That means CO2 formula is like this, which is linear. And in case of H2O, we have oxygen in the middle, and we have two hydrogen on two sides of it. And this is a bent uh, diagram because we have two lone pair on the oxygen, and that's why these lone pairs actually make a repulsion with these hydrogens, and this hydrogen gets a little bit bent instead of a linear structure. So that means in the diagram, from here we can see that this red ones are linear, and these white ones are bent. That means this white spheres or molecules are H2O or water, and these red ones are CO2 or carbon dioxide. So from here you can see that we have 1, 2, 3, and 4 carbon dioxide, while we have 1, 2, 3, 4, 5 H2O. So here we have 4 CO2 and 5 H2O. Now, to know the empirical formula of the hydrocarbon of which combustion we are getting this number of CO2 and H2O, we have to find the number of carbon and number of hydrogen which are being produced here, and just finding that we can find the empirical formula. So as we see that in one molecule of CO2 we have one one atom of carbon. So in four molecule of CO2 we will have four molecule of carbon. So number of carbon atom here is 4, and from here you can see that in one H2O molecule we have two hydrogen. That means in 5 H2O molecule we will have 5 times 2, 10 hydrogen atom. So um, that means the number of hydrogen in 5 H2O is 10. So, and to know the empirical formula we have to find the smallest possible whole number ratio of these two number. So if we write it this way, 4 is to 10, and if we can we can um, we can divide this 2 by 2, and we can get 2 is to 5. That means the empirical formula for this one will be C2H5. So C2H5 is the empirical formula of the hydrocarbon from which uh, combustion we are having this 4 CO2 and 5 H2O in the diagram given.